So imagine a cable that literally shoots invisible lasers down a glass tube just to, let you watch a football game at a sports bar. Welcome to today's deep dive.
Yeah, it sounds a bit like sci-fi, but it's really not.
Exactly. We're looking at what seems like a totally mundane spec sheet from HDTV Supply today, but it's actually hiding this wild technological secret. We are talking about the Avenview FO8K-DP-30-MM DisplayPort cable, and our mission today is to figure out why on earth a single 100-foot display cable costs $660.
Right, because at first glance, it just looks like a standard computer cord.
Hmm.
But it is actually a pretty crazy engineering solution to a brutal physics problem. I mean, pushing high-end video over long distances just creates this massive data bottleneck.
Let's talk about that physics problem for a second, because 100 feet doesn't really sound that far until you realize what you're actually trying to send, right?
Oh, for sure.
I mean, I think of it like trying to shout a really complex password to someone 100 feet away in a crowded room. After a few feet, the syllables just kind of blur together.
That is actually the perfect way to look at it. Because, well, traditional copper cables rely on electrical signals.
Yeah.
And over 100 feet, you run into severe electrical resistance and electromagnetic interference.
Right, so the signal just gets lost.
Exactly. It undergoes attenuation, which just means it loses power. But by the time it reaches the display, your pristine 8K video has basically degraded into unreadable static.
And we are talking about a serious amount of data here for 8K. The specs say this cable is built for 8K at 60 hertz using a high bitrate 3 or HBR3 assembly,
Right.
which means it's pushing 8.1 gigabits per second per lane. And since DisplayPort uses 4 separate data lanes simultaneously, you're actually multiplying that 8.1 gigabits by 4. So no wonder copper failed.
Oh, yeah, absolutely. It doesn't stand the chance.
So how does this $660 cable actually get the signal across the room intact?
Well, what's fascinating here is it completely abandons electrical transmission for the heavy lifting. It uses active optical cable technology.
Okay, wait, so it's optical like fiber internet?
Right at the transmitting end, the cable literally converts that massive electrical audio and video signal into light. It shoots those lasers down a multimode glass fiber optic line.
Multimode meaning what exactly?
It just means the core is large enough to allow multiple light rays to bounce down the cable simultaneously, so it can carry all that high bandwidth data at once. Then the receiver just decodes it back into an electrical signal.
Wow.
So it's essentially shining a flashlight in Morse code across that crowded room you mentioned earlier. The light stays perfectly crisp no matter the distance or the ambient noise.
Okay, but hold on. If shooting light down a glass tube completely solves the attenuation and interference issues, why does the spec sheet describe this as an optical fiber and copper hybrid? Like, if fiber is so superior, keeping copper wires inside the casing seems like a step backward to me.
Yeah, I mean, it seems counterintuitive, but lasers are primarily unidirectional. They're designed for blasting massive amounts of data one way.
Oh, I see. So they can't talk back.
Exactly. You still need copper for the essential background communication that requires those low-speed, two-way electrical handshakes.
Like what kind of handshakes?
Well, for instance, hot plate detection. So the devices actually know they're connected to each other. And HDCP, the high bandwidth digital content protection.
Ah, right. The anti-piracy stuff.
Right. But fiber just isn't designed to handle those basic security handshakes efficiently. So the copper serves as a dedicated line for the device communication, while the glass fiber does all the heavy visual lifting.
Okay, so you essentially have a hybrid data highway inside a single casing. That solves the physics problem for sure, but it kind of creates a market problem. Because who has the budget to buy 100-foot, $660 hybrid cables? I mean, looking at HDTV Supply's catalog, this really isn't aimed at someone just setting up a home theater, right?
Oh, not at all. Their catalog features dedicated portals for government purchasing and even systems for sports bars running up to 160 TVs.
Wow, 160 TVs. So what does this all mean for you, the listener?
Well, in those massive commercial spaces, your source computers aren't sitting right under the television. They are centralized in a matrix switcher.
Which is like a big routing hub.
Yeah, it's a routing hub kept in a secure, distant server closet. And that hub distributes multiple video sources to dozens of different displays.
And when the matrix switcher is 100 feet away from the screen, you still need absolutely zero loss resolution.
Precisely. You just can't have the big game lagging or dropping pixels because the signal is fighting through 100 feet of electrical interference. This specific cable basically guarantees crystal clear 8K over that massive commercial footprint.
It definitely shifts your perspective next time you're sitting at a high-end sports bar. I mean, when you look up at that giant screen, you aren't just looking at standard wires hidden behind the drywall. You are literally watching lasers shoot video data across hybrid glass fiber networks.
It is pretty wild to think about. And honestly, that leads to a much bigger question for the future. I mean, we are already at a point where crossing a single commercial room for 8K video requires converting electrical signals into light.
Right, which makes you wonder what happens when display technology inevitably jumps to 16K or even 32K. Like, if we are already hitting the physical limits of copper and relying on hybrid glass fibers today, well, will the average home office eventually require built-in fiber optic lasers just to plug in a basic desktop monitor? Something to think about.